Hi, in this video we will be discussing the proper use and calibration of a pH meter. To begin, unscrew the pH meter from its cap. The cap contains a salt solution and is important not to spill this solution as it will be important for storing the pH meter later. You can then rinse off the pH meter with deionized water and wipe it with a chem wipe. Afterwards, you can begin to calibrate the meter using the buffers. So, calibration and use of a pH meter. To calibrate the pH meter, we are going to be using a series of buffers to provide an accurate guideline for the pH. First, we rinse off the pH meter in deionized water and wipe it down with a chem wipe. We then insert the pH meter into the pH 7 buffer. Through the pH meter screen, we will start the calibration process. Once the pH level has stabilized, we will then rinse off the pH meter again with deionized water and wipe it again and move on to the pH 4 buffer. For the pH 4 buffer, the same steps will be repeated. The pH meter will be rinsed off with deionized water and wiped with a chem wipe. It will then be inserted into the pH 4 buffer and following the calibration instructions on the pH meter screen. Congratulations, your pH meter is now calibrated and ready for use. But how do you use a pH meter? Well, first, you will rinse off the pH meter in deionized water and wipe it down with a chem wipe. You will then insert the meter into the solution that you are trying to measure. You will then record the value that appears on the pH meter screen. Afterwards, it is important to rinse off the pH meter in deionized water and wipe it down with a chem wipe. The pH meter should always be stored in a beaker of deionized water in between uses. After the pH meter is completely finished being used, you must rinse it off in deionized water and wipe it off with a chem wipe. You will then screw the pH meter back into its salt solution cap. Speaking of strong acids and weak acids, what exactly are they and how do they compare? Well, a strong acid is an acid that dissociates completely in solution. By contrast, weak acids do not dissociate completely in solution. They only dissociate partially. This property is important in the formation of solution equilibriums. Because strong acids dissociate completely, the reaction is not reversible. However, because a weak acid dissociates partially, the reaction can be reversible, and the reaction tends to favor the side with the weak acid. Addition of more strong acid or base can shift a solution's equilibrium. It can also shift the pH. This can be minimized by the use of buffers. Previously, we discussed the use of buffers in calibrating a pH meter. But what is a buffer? A buffer is usually a weak base or weak acid that resists changes in pH. Buffers work by neutralizing any added acid or base within the solution. The weak base and weak acid bond to any additional hydronium or hydroxide ions, neutralizing them. However, every buffer has a capacity. A buffer can bond only so much, and once all the weak acid or weak base is bonded and used up, the buffer will break. The solution will no longer resist changes in pH when strong base or strong acid is added. Congratulations, you now know how to calibrate and use a pH meter. You also learned a little bit about weak acids and strong acids as well as their buffers. Thank you for watching.